I think it's fine. Maybe I'll just do signal. Perfect. Afternoon, everyone, again. Um, my role here basically will be to take all of us through the Edge software and demonstrate how simple and practical it can be for you to, in the comfort of your bedroom, simulate your building and take it through the whole Edge certification process. And how, as Lola talked about, how the software can be is kind of very intelligent to be able to even predict your energy use, your final energy use of your building, your final water use of your building, and the new emerging market coming up around the carbon footprint of your building as well. So yeah, we have the what we want to do is to look at a three-bedroom house here in Lagos with the building dimensions as shown. We have total size of 136 square meters. The living room area 30 square meters. The bedroom area 60 square meters. The kitchen 15. The dining area to 15. Toilet 6, utility 4, balcony 4. An average family of 4 people. Floor to floor height of 3. They have a small irrigated area of around 60 square meters, external parking of 40 square meters, and no swimming pool. The family is more of a middle class, but no swimming pool yet. Then the building length, the dimensions of the building, equal length of 8 meters round. And some of the measures we want to implement in the building are around the window to wall ratio. Very critical when designing buildings is to look at what's the dimension of my windows to my walls. Why? Because we want to look at the heat gain into the spaces, how we are able to, depending on looking at our climate, how we are able to reduce the heat gain, which ultimately impacts the energy use in the building. We are going to be having some insulation in the roof as well. We will not be insulating our ground floor, but we are going to be calculating what we call the U value, the amount of heat that can transmit between the materials. Also, for the external wall, we'll be specifying a good quality glass and make sure that all our lights, both internally and externally, are all LEDs. For the water, we'll be looking at low flow shower heads, which we are going to be specifying around 8 liters per minute. Low flow faucet in the bathrooms, around 3 liters per minute. Having a single flush system of 5 liters per minute, and our kitchen sink faucet around 8 liters per minute as well. In terms of the building construction material, in total, the bottom floor construction will be our normal reinforced concrete around 150 thick. Then the steel rebar will be 15 kilograms per meter squared. The roof structure, our normal aluminum sheets on timber rafters. The floor finish ceramic tiles. The external wall as well will be hollow concrete blocks, 200 and 150 respectively. The window frames, aluminum, and the window glazing, single glazed 6 And since we are not going to be having additional insulation of in addition to our wall material, we will just be ensuring that we choose no insulation in material as well. So practically, let me take us through that we've done. So this is how the Edge app operates. We have 4 sections. The design sections, where you are able to input all the design parameters of your building, as I went through with us right now. Then Edge is very intelligent, where it uses your local climate data of the environment. So it is very, very important to choose the country, then the city where the project is. So in Nigeria, from the database, we have a whole number of cities, from Abeokuta to Maiduguri, as Lola has shown us, and evaluating to Jos, where the climate is kind of different. We're evaluating how the weather impacts the buildings as well. So that will be the first step. The second step will be around the administrative staff, which will be to input the project details and the sub-project details, which around the name of the project, the stage of the project. Are you going through the preliminary stage of certification, or you are going to the post-construction stage of the certification? What type of building? Then you are able to input the building data that we talked about, around the number of bedrooms you have in there, which we stated as 3, the number of homes, a single family home, the average area of your unit, 135 square meters, the number of floors above ground should be 1. So you are able to input 1. The number of floor below grade, 0. The floor to floor, we indicated as 3 meters. Then the roof area, 130 square meters. So the bedroom size, 60, kitchen 15, dining area. So you are able to input all this. The living area, 30, toilet 6, utility 4. Then the building dimensions as well, the north, east, west, or as it applies to your project. Maybe you have your elevations around the northeast, southeast, or southwest. You are able to put this in the app, and the app can intelligently evaluate the heat gain into the space vis-a-vis the window to wall ratio as well. So very critical aspect of the design is, what kind of building am I designing? Am I going to have an air conditioning unit in my building, or I don't need an air conditioning unit in my building? Largely, everybody starts out without air conditioning system for low income houses, but eventually when income level goes up a bit, or when the weather becomes very unfavorable, we all input air conditioning system. So it's always better to have your simulation with air conditioning system in there. So the next step is to, after having your design, is to go to the energy, trying to evaluate what are the measures under energy I can choose, so that my building can be as efficient as possible, and with even a low payback time, and the cost of energy use in my building will be reduced. Very critical part of assessing the energy use in any building is the building envelope. So the building envelope determines how you want to box yourself into the space. What is the amount, depending on the material of wall you are using, what is the heat gain the material can withstand and deflect as well. So the first thing will be to have a window to wall ratio specified, which is basically below the base case. The base case here in Nigeria is around 20%. So having a lower window to wall ratio of 15% should be a good one to go. The next step, as we indicated, is we will be having insulation in our roof, and the insulation will be basically the air gap we have there. So we'll be having insulation in the roof. But the overall aim is to make sure that you are able to at least take your project or to be 20%, achieve the 20% standard as Lola talked about. The next will be evaluating the U value, the heat transmission through your floor slabs as well. The next will be by just a click of button, you are able to see real time how these parameters impact your buildings as well. Insulation of exterior wall. Just waiting for the internet to, yeah. So insulation of exterior walls, having energy efficient glass, maybe a double glazing or single glazing. You could see from each measure how progressively the energy savings are moving. The next will be hot water used in the building, which is very critical, and you will see the impact of efficient hot water use in the building, which largely is a culprit for a whole lot of energy consumption in the building as well. We talked about having energy efficient lighting in our internal areas and external areas. So with this, you can see clearly that with these measures being implemented on the energy side, you are able to meet at least, you've gone past the 20% and you are around 30% of your building of the energy savings as you use the building. Very critical is the cooling system I talked about as well. And making sure that at least you go for an high efficient energy, an high efficient AC systems. Basically, I don't know if we have more of the energy labeling system, but looking at the star rating, the higher the star ratings, the more energy efficient they become. They are actually. So that means for energy, we are actually doing pretty well. You can aim higher and go towards the edge advance around the 40%. But let's move to water now. The water, we stipulated that we will have a low flow shower heads of 6 liters per minute. We will also have a water efficient faucet for all bathrooms of around 2 liters per minute. Then we will have a single flush system of 5 liters per minute. So you are able to choose from here the type of flush. Even if you have a bucket flush system, you are able to choose from here and just input the liters of flush in the system you have. So the next area we talked about was having a low flow faucet for kitchen as well. for the kitchen sink, which we specified around 8 liters per minute. You see, this is gradually increasing our water efficiency. And if you look critically, you will see that some of the measures are around shower heads are also positively impacting the energy because of the hot water system, the energy you will need. So if you are saving a whole lot of hot water, that means you are reducing the energy use you will need to eat that also. So for energy, water, we are okay now because the minimum standard is around 20%. So we move to the material section. The material, we will have our normal in situ reinforced concrete, and as we indicated, we will be going for a 150 mm concrete slab. With steel rebar of around 15. Then for the floor finish, we estimated that it should be definitely ceramic tiles with a thickness of 8 mm. Then the roof construction, we said it to be aluminum sheet on timber rafters. Then the gauge of the aluminum, maybe 0.5. Then the external wall, we said it to be hollow concrete. The base case is here, hollow concrete of 200 mm. So you will see that the edge app is also estimating the U value, which looks at the heat gain into the space. And for the interior wall, we said it to be hollow concrete as well. 100 mm. Then the window frames already aluminum as the base case, we are good. The window glazing 6 mm thick. Then the roof insulation, we said air gap. Around 90 mm or thereabouts, because anything above 100 mm becomes a convection. It doesn't create insulation again. Then the wall insulation, we don't have an external wall insulation, but because we are using the hollow concrete blocks, the air gap also serves as some kind of insulation as well. Then for the floor finish as well, for the floor slabs, no insulation. Just need to save, yeah. So basically, we've been able to go through in less than 30 minutes. In less than 30 minutes, we've been able to go through simulating a building here in Lagos and ensuring that this building is is actually green and meeting the edge standard in a space of less than 30 minutes. So basically, and the predictions from this simulation largely compares to anything you will use, any dynamic model that will take you 2 weeks or 3 weeks to complete. So basically, you will see, and on the top session, it gives you the final water use of your building per month. It gives you even the operational CO2 savings per month. It gives you the final embodied energy use of the building per month. The final utility costs which you have of your building, which you are supposed to be paying around 50,000 naira per month, and these estimates are generally close to what you'll be paying if this is the design of your building, and gives you the final utility cost and the energy savings you'll be making per year in megawatt hour. So largely, I would just encourage us to always log into the app and play with it, put your offices in it, put your homes in it, and let it intelligently show you how you can build green and brand green as well. I don't know if anyone, if you have any question in less than 2 minutes, we can take that as well. Thank you. No questions. Thank you.